Hey, Mr. Maestas here, and today we're going to look at graphing reciprocal composite functions. So we're going to look at an interesting function where we're taking some ideas of parent functions and then graphing the reciprocal of that and seeing what happens as the reciprocal does to a function. So a couple things to keep in mind as I go over this problem. One, we're going to use a step-by-step approach, meaning we're going to take each step of the composite function separately to get to our last graph. Second, when we look at this, we're going to make sure that we have vertical asymptotes wherever our previous graph crossed the x-axis, and I'll talk about that more once we get into the actual problem. Third, it's a good idea to remember what happens on the end behavior of a graph so that we can take a look at the reciprocal and remember that it's kind of like the reverse or I don't want to say the opposite, but kind of the reverse of what's going on. So we'll talk about that again a little bit more when we get to that. And lastly, it's always important to work inside out. So when we're doing our step-by-step graphing, we're going to look at what's the most inside parent function, and then we're going to keep going out as we go along. So I've got this interesting function here, f of x equals 1 over the absolute value of x squared minus 4. And we're going to take this a step-by-step approach, and we're going to start with our first parent function, which is y equals x squared. So we're going to graph y equals x squared, and we know that is a parabola. Looks like that. And we're just drawing a sketch. And we do want to be a little bit precise when we get to a few of these things here. And we'll take a look at the next step of this graph. Y equals x squared minus 4. And so what we're going to do is we're going to take, and we know this from translations, that we're going to take this y equals x squared graph, and we're going to move that down 4 units. So we're down 4 units, and if you can make this reach, you would know that this has x-intercepts at 2 and negative 2. So we're going to go ahead and graph this parabola. And we know that the x-intercepts are 2 and negative 2. If we set this equal to 0 and solve for x, we get x equals 2 and x equals negative 2. Now we're going to move to step 3, so I'm just going to go up here in step 3. We're going to add the absolute value part to it, and we know that an absolute value makes everything positive. It doesn't change the curvature at all, but it does make everything positive and make it reflect around the x-axis. So we're going to take this graph, we're going to apply the absolute value to it, which is going to take everything that was below the x-axis and put it above the x-axis, without changing the curvature of the graph. So these parts are already above the x-axis. They're going to stay above the x-axis, something like this. And this part is going to now be reflected about the x-axis. And we've got something that looks like that. Okay, lastly, we're going to go ahead and take the reciprocal. So now we have to think about, what does a reciprocal do? Well, I think one of the easiest things we can think of the reciprocal is the y-intercept. The y-intercept is when x equals 0. So if we plugged x equals 0 in here, we would see that 1 over the absolute value of negative 4 is 1/4. So instead of having a y-intercept of 4, we now have a y-intercept of 1/4, which should make perfect sense, because if we had 4, the reciprocal of 4 is 1/4. So that's where we are for this one. So now the other thing I mentioned that we had to keep in mind was this number 2 here, that vertical asymptotes happen where the previous graph had x-intercepts. Here are the x-intercepts at 2 and negative 2. So at these x values, we're going to have vertical asymptotes. Now, why would we have vertical asymptotes at those x-intercepts? Well, keep in mind that the y value, that the x value here is negative 2. The y value would be 0. If the y value was 0 and we did a reciprocal of that, we would have 1 over 0, which we all know can destroy the planet. No, it's just undefined. And whenever we have 1 over 0 that's an undefined statement, we would have a vertical asymptote. So in this case, if we plug -2 in here, we would get 1 over 0. We know that that's a vertical asymptote, so the vertical asymptotes are going to be where the previous graph had x-intercepts. Now, the rational doesn't do anything to our positive or negative values. It just kind of makes them smaller, makes them increase at a different rate. So we have to make sure that we keep the positive values in this all positive. Well, we have to approach the asymptotes. Let's think really quickly about what's going on in terms of the end behavior. As this graph right here, as x goes out to infinity, the y values are going to get larger and larger and larger, infinitely larger. Well, now think about what we do when we take the reciprocal of that. If this value, which was our function, x squared minus 4, absolute value of that, if this value was getting larger, 1 over a really large number gets closer to 0. So as x goes out to infinity, this graph, when taking the reciprocal, actually should go closer to 0. So our y values are actually going to get closer to 0. We're going to have a horizontal asymptote right there. As we get closer to 0, this number gets infinitely small, which makes it, when we do the reciprocal, getting larger and larger, which is why as we approach 2, we go up to infinity. And another thing to think about too here is that we approached our vertical asymptote, we approached our horizontal asymptote, and we remained above the x-axis, which is what we have to do. We have to remain above the x-axis. Now, this side is going to look exactly the same. We have an even function here. Let me make that look a little bit better in terms of its symmetry. Again, this is just a sketch. Finally, we have this little u part here. Again, it all has to stay positive, and they have to approach the vertical asymptotes. So the easiest way to do that, we can't go underneath, we can't go down here because it has to stay above the x-axis. So the easiest way to do that is to approach the asymptotes from both directions on the y-intercept. And you can think of it also as we approach 2, these numbers are getting closer and closer to 0. The y values are getting closer and closer to 0. If the y values were getting closer to 0 and we do the reciprocal of that, we're actually going to infinity. So this is where I get back to where number 3 here, we're actually doing kind of the reverse. Instead of going out to infinity, we're getting closer to 0. Instead of getting closer to 0, we're going out to infinity. And all those think about the y values. So this is our graph of y equals 1 over absolute value of x squared minus 4. I think before I leave you off here, what I want you to remember is a couple of rules about reciprocal graphing. The important thing is that when you do the reciprocal part, the x-intercepts of the previous graph are the vertical asymptotes of your final picture. The other thing is the reciprocal does not change the positive or negative values of y. Here, the whole graph was above the x-axis, so here the entire graph must remain above the x-axis. It does not change the values being positive or negative above or below the y-axis. This is or x-axis. This is very, very important. Lastly is use a step-by-step approach. You'll get the answer, and make sure you just double check to make sure that you've done all of the steps properly. Okay, that's it. We'll see you later.